first problem we're gonna talk about is an object, a box sitting on a table. Let's say box is 10 kilogram, and let's say mu s is 0.7 and mu k is 0.5, and there are several applied force acting on this box. We're just going to call it simply applied force. We're going to try to find the normal force, force of friction, net force, and acceleration, of course. So first thing we're going to find the weight of this box. So let's draw the free body diagram at the y direction. Of course, weight would be mg. So m is, let's say 14 kilogram. Let's say 14 kilogram. We're going to start with 14 kilogram. So let's say m is 14 kilogram and g is, we're going to use g is equal to 9.8 meter per second squared. So g is 9.8 Newton. So the normal force has to be equal in magnitude and opposite in direction, because there is no other upward force directed on this box. So this is equal in magnitude and opposite in direction, because there is no upward pulling force acting on this box. Alright, what else we can find? We can find the maximum frictional force possible. So maximum frictional force is, of course, mu s Fn. Mu s is 0.7 times Fn is 137.2, 96.04 Newton. Now we're going to find the Fk, mu k Fn. Fk is 0.5 times 137.2, 0.6 Newton. Of course, now what we're gonna explore is what gonna happen, what would be the force of friction, normal force, and net force and acceleration when you apply different force to this box. One thing you know that in order to move this box, you have to apply at least 96.04. Anything less than 96.04, the box won't start moving. Once the box start moving, all you need to apply is 68.6, because you have to first overcome the inertia. To overcome the inertia, you need 96.04, and once you overcome the inertia, then you have to apply only 68.6, which you can understand by friction graph. What does that mean? This is Fk, which is 68.6, and this is Fs. Fs can be, Fs is less than or equal to, what is it? 96.04. So anything less than 96.04, the box won't move. Once box start moving, then it falls, because object in motion like to stay in motion. Then you have to apply only 68.6 Newton. Get it? Now let's see what happened when you apply, when applied force is 5 Newton, 20 Newton, 50 Newton, I don't know, 96.4 Newton, and 100 Newton. Alright, force of friction, what's gonna be the force of friction and what's gonna be the net force? Let's see the normal force. Let's first find the normal force of this box. Normal force, force of friction, net force, and then acceleration. Okay, normal force is going to be the same because there is no upward force acting on this box. So normal force is going to be 137.2, 137.2, 137.2, 137.2, 137.2. That's obvious. Force of friction. Force of friction is 5 because 5 is less than 96.4. 20 because 20 is less than 96.4. Why 20? As soon as you apply 20, the table will apply 20, which is equal in magnitude but opposite in direction, to keep the box at rest. 50 is less than 96.04, so 50. 96.04 is equal to 96.04. So of course this is 96.04, and 100. Force of friction all of a sudden is going to be 68.6. Alright, good. So the net force is 0, net force is 0, net force is 0. Alright, so acceleration is 0, acceleration 0, acceleration 0. This is acceleration 0, but this object is moving with constant velocity. This object is rest, this object is rest, this object is at rest. Alright, so that is the problem number 1. Now we're going to make this problem a little bit more interesting. Now we're going to see what happened when someone pulled by a rope. Okay, let's take a look. What happened, same problem, but now we're going to make it a little bit more interesting by what? By doing what? By having someone to do what? To use a rope. Use a rope to do what? To pull upward direction. Alright. So let's see what that gonna do if someone actually do applied forces now. We'll find out. 5 Newton at, I don't know, 30 degree, 20 Newton at 45 degree, and 50 Newton at 60 degrees. So what we're gonna do with this? We're gonna do 5 cosine 30, 5 sine 30, 20 cosine 45, 20 sine 45, 50 cosine 60, 50 sine 60. So this is probably 14.14, 14.14 of 3.30. Okay, good. Now what we're going to do with this, we can erase this to make room. Now next thing we're going to do, we're going to find the normal force, and normal force definitely not going to be 137, is because there is an upward force. There is an upward force. What does that mean? That means this one has two components, x component and the y component. Y component help the table. Okay, you get it? Okay, so this is the y component, this is the y component, this is the y component that helps the table. What does that mean? That means the 137 minus 137.2 minus 2.5. So normal force would be 134.7. All right, let's do the other one. 137.2 minus 14.14, 3.9 Newton, Newton, Newton. All right, so this is normal force, which helps us to find force of friction. So what would be the force of friction? I'm gonna take this off and I'm gonna move it to different direction. So I'm gonna move it over here. Okay, so I'm gonna move it over here. Okay, so over here. Okay, good. Now I can erase this guy. Force of friction. So force of friction would be mu k Fn, mu k Fn, mu k Fn. So mu k is 0.5 and Fn is 134.7, 0.5, 123.06, 0.5, 93.9. So this one would be 6.95. Alright, good. Now that's force of friction. Now what are we going to find? Net force. So how can we find net force? Finally, we're going to get to use the thing that you have been thinking of. What is the good use of this? So now we're going to put that in a good use. This one. Alright. This one. And this one. We're going to put them in good use now. Alright. So how can we do that? Very simple. So now net force is of course the x direction, so 4.3 minus 67.35, 14.14 minus 61.53, 25 minus 46.95, and we're going to calculate them. Let's see what happened. 1.95. Okay, so this is our net force. Now it's time to find the acceleration. So what would be the acceleration? This divided by 14 is meter per second square. So now you're probably thinking how on the wall a friction can be negative, how on the wall the acceleration can be negative. Okay, let's take a look. Hopefully you see this. I'm going to roll this. If I roll this pen, you see this pen eventually stop. Why? Take a look again. I'm going to roll this pen and this pen eventually stop. I'm going to roll it even harder. I'm going to roll it even harder. And you see this pen stop. Why? Velocity is this direction, but force is net force is this direction, and net force caused by friction. If net force is negative, velocity is positive to the east, net force is negative to the west. If net force is negative, then acceleration is negative without any exception. Get it? Good. This is a famous example, but Aristotle would say that the object slow down and stop because object get tired. Newton would say, well, velocity is this direction, okay. But object slow down, that means velocity decrease. Why the velocity decrease? Because of friction. What friction does? Slow it down. How? Because the net force. Because the net force is opposite at the direction of the motion. If net force is negative, then acceleration is negative. I think you get it. Little tricky. Inclined plane. When we talk about inclined plane, what do we talk about? Let's see. You have a plane and you have a box. Let's say 10 kilogram box, and acceleration due to gravity acting on it. So acceleration due to gravity, this is Fg, and Fg has two components. One is perpendicular, Fg perpendicular, which is normal force. One is Fg parallel, which is opposite to the force of friction. Okay, that's very simple. That means the gravity has two components. One is the parallel component, one is the perpendicular component. Now let's calculate them. All right, so Fg has two components. I'm going to put it here. Fg has two components. Now we're going to consider three different scenarios. First scenario, we're going to use all scenario. We're going to use 10 kilogram, and we use different angles. Let's start at 30, 45, and 60. You will see that as you increase the angle, the acceleration acceleration will also increase. Acceleration also increases, is going to approach to 9.8. You see that. So if theta goes to 90 degree, acceleration goes to g. All right, you'll see that. Okay, so now what did I do wrong? I put the equal sign. What I supposed to do? I supposed to write two component of the gravity. What are the two component of the gravity? Fg parallel and Fg perpendicular, which is the normal. Fg parallel and Fg perpendicular, which is a normal. Fg parallel, Fg perpendicular, which is equal to normal. All right, good. Now you're gonna write mg. Of course, this one is sine theta. Mg cosine theta, mg sine theta, mg cosine theta, mg sine theta, and mg cosine theta. Okay, good. Now the next thing you're going to do is replace m by 10, replace g by 9.8, and sine 30 degree, 10 9.8 cosine 30, 10 9.8 sine 45, 10 9.8 cosine 45, 10 9.8 sine 60, 10 9.8 cosine 6 sine 30, 98 cosine 30, 98 sine 45, 98 cosine 45, 98 sine 60. All right, now what we're going to do is we're going to also take this out, copy, 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 paste. All right, I can put it over here and make it small. Okay, so it's good that you have it over here. So let's continue with this conversation. Now what we're going to do, we're going to find force of friction. Force of friction is, remember, force of friction is Fn, which is this one. Fn is this one. So Fn. All right, Fn times mu k. So let's use that fact. Fn times mu k is force of friction. So Fn times mu k, so 84.9 times 0.5, because mu k is 0.5, and this one is 69.5 and 49.5. So these are 0.5. Okay, good. Now we found the force of friction. Now what are you going to do? You're going to find the net force. So net force would be what? Net force would be the parallel component of the gravity minus the force of friction. So the parallel component of the gravity is what? The parallel component of the gravity is 49 minus 42.45, 34.5 minus 69 minus 34.5, 84.9 minus 24.5. So these 60.4. Now finally we're gonna get the acceleration of the box when is on the inclined plane with 30 degree, 45 degree, and 60 degree. 3.45 meter per second square, and this one would be 6.04 meter per second square. So as you see that as theta goes to 90 degree, acceleration goes to 9.8 meter per second square or to the g. Alright, so because this is 30 degree, this is 45 degree, and this is 60 degree, and if you do 90 degree, it's gonna be 9.8.
Brought to you by Brilliant.org.
Bari Science Lab to fall in love with math and science.